So in previous videos, we talked about acceleration, velocity, and position, but we didn't ever really talk about what drives acceleration. And so in today's video, we're going to talk about what drives acceleration, which is force, and we're going to talk a little bit about Newton's laws and how they relate to forces and acceleration. So we know that in a car, when we are accelerating, it is the engine that is actually causing us to accelerate. And the engine is applying a force to the car, which is causing it to accelerate. So force is actually driving acceleration. Isaac Newton, who was alive in about 1600, described the way that forces and acceleration interact with each other. And he came up with three different laws. And we're going to go through those three laws. And then we'll talk about what those laws have to do with rocket science, because they're sort of fundamental in describing rocket science. So let's read these laws first of all. We'll read them one at a time and then we'll talk about them. So his first law says an object at rest remains at rest, and an object in motion remains in motion at a constant speed and in a straight line unless it is acted on by an unbalanced force. If a car is driving at a constant speed down a very straight road, and we ignore air resistance or anything like that, and it just keeps going straight, unless we apply something like brakes to it, right? Or unless we turn the wheel and we make it turn, which is applying a force on the car also. It will just keep going in the same direction. So Newton's first law basically says things will just keep going in straight lines at a constant speed unless we apply some sort of a force to it. So when we turn our car, we're also applying a force. So when we are going, for example, eastward, we pull up to a stop sign, we decelerate, we turn our car, and we accelerate in, say, a southward direction. And all of those are applying forces. We decelerate, we turn the car, and then we accelerate again. And one you're using brakes, and one you're using your acceleration. Your engine is causing it to accelerate. So what happens when we go around our roundabout, our lovely roundabout? Well, so in a roundabout, remember in a roundabout, we could be going at a very constant speed around the roundabout, say 20 kilometers per hour around the roundabout, but we're changing direction all of the time, and that is an acceleration. So what is the force that's causing that? Well, the force that's acting on your car and changing your velocity is actually the tires interacting with the road, right? You're turning your wheel and your tires are applying a frictional force on the vehicle to keep it going in a circle. If you go into a roundabout and the roundabout is covered with ice, then you don't have that friction on your vehicle anymore, and you will just sail right through the roundabout. You will not be able to go around that turn because you won't be able to apply that force to change your velocity or to cause that acceleration. All right, let's talk about Newton's second law. The second law talks about acceleration and mass. And it says the acceleration of an object depends on the mass of the object and the amount of force applied. Okay, so what does that mean in a practical sense? That means that mass makes a difference. So let's say that you have a car and you have a truck, and you put the exact same engine in a car and in a truck. If you get in that and you have a drag race between the car and the truck with exactly the same engine, the car is going to win every time, right? Because they both apply exactly the same force, but the mass of the car is so much less that it can accelerate much faster than the truck can accelerate. right? We sort of get this intrinsically. We know that, if you try to push on a boulder, you're not going to be able to move the boulder very easily. But if you push on a little rock, you can move that rock pretty easily. You can apply the same force to a boulder and to a small rock, and one will move very quickly, very easily, and the other one won't. And that's because mass and acceleration and force are all related to each other in Newton's second law. What does this have to do with rockets? Well, rockets come in all shapes and sizes, and some rockets are very, very large, and some rockets are pretty small. The Electron rocket is designed to take things that are about the size of a stove up to orbit. They take things that are like 300 kilograms at the absolute largest up to orbit. While the Saturn V rocket takes things that are, incredibly huge up to orbit. The Saturn V rocket actually delivered people to the moon. And so the Saturn V is just massive, while the Electron rocket is very, very, very small. And so when each of these rockets start to accelerate, when they're on the pad and the engineers push the button to go, the Electron rocket almost jumps off of the pad. It accelerates very, very, very quickly because it is very light. It has almost no mass compared to the Saturn V. And the Saturn V, if you've seen videos of the Saturn V, it is very, very, very slow getting off of the pad because it is so massive. It has an unbelievably huge amount of thrust, but because it is so massive, it rises in the air very slowly. It accelerates very slowly. And this has to do with Newton's second law, that force, mass, and acceleration are all related to each other. Even though the Saturn V has significantly more thrust than the Electron rocket, it still accelerates much slower than the Electron rocket because the Electron rocket is so much smaller. All right, let's talk about Newton's third law. Newton's third law helps us understand how thrust works on a rocket. And his third law says whenever one object exerts a force on another object, the second object exerts an equal and opposite force on the first object. Okay, so a good example of this is if you are on a boat and you fire a cannon. When you fire that cannon, the cannonball goes off, but the boat will go in the opposite direction, right? So the cannonball goes to the right, the boat goes to the left. Now, the interesting thing is that the cannonball has significantly less mass, so it goes off very fast. The boat has a lot of mass, and so its motion is very slow. Okay? And we'll explain why that is in a later video. But it's related to Newton's second law, which is the fact that acceleration and mass are related to each other. So, what does this have to do with rockets? Well, we'll get into the details of this later, but that fire stuff coming out of the back of the rocket, that's not just like pretty lights and fire coming out. That is actually stuff coming out of the back of the rocket, right? And so just like a cannon on a boat shoots cannonballs and then the boat moves the other way, when a rocket fires, the stuff coming out of the back acts like a cannonball, and it causes the rocket to go in the opposite direction. And that's what Newton's third law talks about. So, in summary, Newton's three laws talk about how forces and acceleration and mass are all related to each other. And we're going to use these concepts to really talk about how rockets work and how thrust works. And that will be in upcoming videos. Thank you very much.